Hi, my name is Zaheen Ahmad, and now I'll present our work, Marginal Utility for Planning and Continuous and Large Discrete Action Spaces, with my co-authors Lelis and Michael Bowling at the University of Alberta. In decision-making problems, planning algorithms are used to find the best action from among a number of possibilities. Actions are repeatedly sampled to search over their outcomes in order to identify the action with the highest valued outcome. Unfortunately, in large action spaces, the number of samples needed by planners to find good actions can be prohibitive. A commonly used approach to improve the efficiency of search is to train a function approximator to learn a policy. A policy places prior probabilities over which actions should be sampled in order to guide search. However, the objective used to train policies attempts to increase the expected values of all generated actions and ignores that the policy is being used to generate candidates for search where only one generated action need have high value. We propose that learning explicit candidate actions for search by optimizing for the maximum over actions is a more suitable training objective, as the planner itself is aiming to find the best action. While the max may be a more appropriate objective, it has a poor optimization landscape for gradient methods due to sparse gradients. We show that by instead using marginal utilities of the actions, the max objective can be reformulated into an objective better suited for optimization. The marginal utility of an action is the utility gained by choosing it over another action. Consequently, the max value can be rewritten as the sum of marginal utilities of all the actions. Placing a stop gradient in front of the max in the new equation ensures that each subsequent action is improved without compromising the values of previously generated actions. We evaluate our approach for generating actions in a single decision domain with two-dimensional continuous actions and stochastic outcomes, and one with discrete actions. We compare the performance of search using the actions generated by marginal utility against those produced by max and a policy. Our results show that the expected value achieved by search using marginal utility is significantly higher than with the policy in both domains and better than max in the continuous setting. Marginal utility is tied with max in the discrete domain. To summarize, in our work we identify the importance of generating good candidate actions for search. We show that learning a policy to generate actions is not ideal and that max is a better training objective. Then we demonstrate that the marginal utility objective is an easier to optimize version of max. More details about our results and our experiments can be found in our paper, and if you have any further questions, please write to this email address. Thank you.